some, it depends on where you look and what parts of the state you look at. If you go look in more cattle ranching country where people mostly graze it and they keep it, you find more susceptible kochia. If you come into chem fallow land, you find much more resistant kochia. So this is a picture in Montana. What do you notice about the field? Everything else is dead in that field, right? Everything else is dead in the field. So why am I bringing this back to integrated weed management? Well, they called me up and they said, I took glyphosate out there. I sprayed 32 ounces of glyphosate, killed everything except some of this kochia in the field. So I went back with 64 ounces and I did the same thing and none of this kochia died. And then I went back and I put on 96 ounces of glyphosate. And if you did that, okay, this picture came from 2008, no, right when I started, 2018. If you went out and did that today, would you have any money left to farm? So that's why I'm saying you have to come back and think about the integrated pest management. Before, when glyphosate was cheap, okay, you could get away with doing something like that. But now we find ourselves in a situation where that it was, since it's after 6 o'clock, it was pissing money away then, but it's really like, it really makes no sense now. So that's what I mean when I say, think about the principles of integrated pest management. If we're gonna go and put some of this, use glyphosate in where it's become a product that's more scarce, more expensive, and maybe has more value to it, we have to think about how we use it and how we put it into the system a little bit more. So what can we do right now is we can think about maximizing our efficacy. So there's a lot of factors that affect efficacy of our herbicide treatments. There's the size of the weed itself. Maybe some weeds are more susceptible to glyphosate than others. Mallow, you know, prostrate mallow we see, you can't kill that with glyphosate no matter how hard you tried. But then just size of the weeds also. The larger the plant, the harder it is to kill. The environmental conditions, and that really combines both weather and soils and how much soil moisture in there. Maybe soil, not so much for glyphosate because it's not a residual herbicide, but if for other herbicides, soils really make a difference. Mixing of herbicides, preparing the tank mix, what order you do, what products go in there, the quality of your water that goes into that solution, and then thinking about how much water you're spraying, the droplets that you're spraying out, how much contact are you getting, and then it's in some ways the most important, but I also put it at the last. It's herbicide choice and ingredients of your active ingredient choice. But realize that all these can make or break a herbicide application no matter what you choose.
Quality of the water, in what definition? You mean the chlorine content or rate process, or are you thinking that it's better just to pull out of the creek?
I think it's good to test the water. You want to have low turbidity in the water. You don't want to have a lot of dissolved solids. The purer the water you can get, the better the herbicide that will mix. So, I mean, in some ways, hardness. So that would be the chlorine, the calcium carbonate, that would be the manganese, that would be the iron levels. We don't deal with too high of iron levels, but there's a lot of hardness sort of cations. And what happens is if you have really hard water and you don't mix any AMS in there or anything, you have these calcium molecules that are kind of floating around, and that glyphosate molecule goes into that water solution. Well, the way that glyphosate is it has a slight charge to it, so it will pull in all those calcium and chloride ions, and they'll basically go through a process of what's called chelation. It'll make a lattice structure around it, and it'll be all bound up, and then it will have no function. It won't work well at all. So when I mean water as a solution, we should aim to have the best water source that you can given the economics of it, right? You don't want to drive 100 miles to fill up your tanks, but you want to have good, clean water with low turbidity, low dissolved solvents in it, and it's not too hard. The best we can do is not too hard. When people first started spraying glyphosate in Montana, we didn't put AMS into our solutions. And AMS is ammonia sulfate. And what it does is all those calciums and those positively charged cations that are in the water, you know, Clayne probably talked about some of the cations in the fertilizers last week. But, you know, when you have those in there, that AMS basically splits up to an ammonia and a sulfate, and it binds to those hard elements first, and then they bind and they sink out so that the glyphosate can be free to actually bind to the plant. It's when the glyphosate's all covered up with those hard water molecules like calcium carbonate, chloride ions, that kind of stuff, that's when it really doesn't work. And so if you want to get the most out of it, it's good to come with clean water and mix your AMS in there first, get it well mixed and go quick. If you're using an infusion sort of system, you know, it's a little different. Things don't touch each other as much as they did before. But if you have a big tank where you're mixing it in there, you want to use the cleaner water that you can. Any other questions on that? If anyone agrees or disagrees with me, you can just speak up. We're a group, not too big of a group in here. So efficacy is affected by the weed size, how stressed the weeds are, and then herbicide resistance. And the size of the weeds, we want to spray these nice green actively growing weeds, right? When you come back and you try to hit kochia like this, that's already stressed, has probably already been sprayed before, and is just kind of sitting there, that's a really hard thing to kill no matter what herbicide you bring to the game. So here, this kind of comes back to the water thing too. So what can we do in the short term? Our short-term actions, the good water. So do your best to get not too hard of water. Basically in Montana, AMS is required. Some form of AMS is required in the water. Now there are lots of other adjuvants and products that people have out there that are different forms of AMS. You know, they may, you know, Hellfire, or is that what, yeah, Hellfire. You know, there's a lot of different ones that are out there, but they're different pHs and they're sort of different chemical properties. But when it comes down to it, they're really this ammonia sulfate, and that AMS breaks apart into the ammonia and the sulfate to make sure that the glyphosate functions as you go forward. Compatible tank mixes, making sure that our tank mixes that we might choose, especially if we think we're going to switch things up, making sure that those tank mixes are compatible. And we could talk about the salts a little bit. So do you guys know that, you know, we can have herbicide active ingredient molecules that can be carried in different salt forms? We'll say, yeah, maybe kind of. So there's multiple different kinds of salts that can carry molecules. There's three different salts that will carry glyphosate. They make them in different products. And if you have to be careful that you match the right kind of salts with the right kind of salts, or otherwise they can precipitate out sometimes and make a salty layer in the bottom of your tank mix that'll clog everything up and clog filters up and things like that. There's a good example. I didn't bring it with me tonight, but there's a good example of, there used to be this product that was called Landmaster. And it was a 2,4-D and a glyphosate product together. And the thing about putting them together is they both use the same type of salt. Well, a lot of people said, oh, I'll go home and I'll mix up my own Landmaster. And what they did was they chose something that had a different type of salt between the 2,4-D and the glyphosate, which then caused it to precipitate out and then the herbicide to not work well. So when you have to really read the label and look at some of that stuff to make sure you're getting your right salts and it's compatible. And then do a jar test. Just mix them up together a little bit. You know, it doesn't have to be a big jar. It just has to be a little jar like that. We do a lot of herbicide screening. You guys spray hundreds of thousands of acres. I pipette herbicides with a little pipette tip to put, we have these spray chambers, right? And we screen for herbicide resistance or test new herbicides. I'm in there with a pipette doing that. So you can make really small volumes of this stuff and just test to see if it stays together and what it looks like. Better to have a small jar full of something that's not compatible than a big tank that's not compatible. So I think I got all the ones off the last one that I wanted to say. So this kind of herbicides 101, getting the most out of your applications, because really it's what we're trying to do the best we can with the product that we can. So it's important to get good weather conditions. That's the next slide. I'll talk about that. But what's important about the weather conditions is that in small plants is glyphosate is a translocated herbicide. So the plant has to be able to move it around. When we spray kochia that are half dead and sitting there and not doing chemistry, the reason they're not dying is largely because they're not moving systemic herbicides in the plant. So glyphosate is taken up through the leaf surface, and the way that glyphosate works is it stops the plant from making a chain of amino acids. And a chain of amino acids is a protein. So the plant has to be starved for protein. So what do you know about glyphosate after you spray it? You go back out there 7 days later, what does it look like? Nothing happened. Or in some cases, nothing happened. And that's because the plant has to take it in through its leaves, then move it up to the growing point in the plant, and then it stops it from making proteins, and the plant has to starve from those proteins. That's why glyphosate can take a really long time to work. So if it's cold outside and that plant's turned off and it's just sitting there shut down, like a prickly lettuce or something, and you go spray it, chances are it's not going to translocate as well as if it were in a warm, nice condition and it was growing really well. When it comes down to glyphosate, you know, if you're spraying, there's some people are still spraying just glyphosate, but more and more it's not sprayed on its own, it's mixed in a tank mix. But we should make sure that we're using the full rates because we want to keep glyphosate around to use for as long as we can. We don't want to develop resistance too fast. Low levels of exposure lead to quicker resistance. So this comes back to so we want the plant to be actively growing. We want it to be green. We want it to be doing its chemistry, moving water around in the plant. But we also want to apply those herbicides when the temperature conditions are good to get the herbicide into the plant, but make sure that the herbicide also doesn't volatilize or doesn't freeze or different things can happen. So this green area right here is the optimal spray conditions. The red is more marginal, especially, you know, this is super high humidity and 32 degrees. I hope you guys aren't out spraying. You know, it's snowing and you're you're out spraying. And then the wind blows and then you controlled all the weeds in your ditch. But we want to be in this general zone right in here. This is 32, 41, 50 degrees. I'm pretty skeptical of 32 to 50 degrees. Really, we want to be out here in the middle. And so this is the temperature down here on the x-axis, and then this is the relative humidity over here, and this is the delta T value, or how much evapotranspiration, the transpiration rate. So really, you know, from at 50 degrees, with about 50% humidity. That's probably good in a lot of instances for us to spray in the springtime. There's, ideally, we probably want to be up here around 60 degrees in the middle with about 50-60% humidity in the middle. If you come in and the humidity is way too high, you're getting dew, right? And then you're going to spray that herbicide on there and you get a heavy dew and it may run off. On the other end, when it's super hot and dry down here and the relative humidity is really low, this is 30% right here going across this line, and here's 86 degrees. I mean, it's on the marginal end, but if we think about some of our summer and our summer fallow conditions, this is a very typical low humidity kind of day that we have. It may even get, think about this summer, we were way down in there. So when we spray, we got to try to aim for these optimal conditions here in the middle, especially.
More like early morning dew.
Get the early morning dew? As long as it doesn't run. I'd say like that 8 o'clock, 8:30, 9 o'clock, right when the dew's kind of starting to come off and the sun's warmed up a little bit and the plant's kind of growing, and that's when you can really get in there. The research that's come out of a lot of that we've seen is really kind of between 10 and 2 is when they say spray quite often, and you get some of the best results. I think it depends on the herbicide, but we'll just put glyphosate in this context now. I actually took this out. They were talking about spraying clethodim and getting the best results out of clethodim also being in this general thing too. If anybody's growing any of the Clearfield wheats with the Pursuit and Beyond herbicides and having a Mazamox in there, a lot of times people can get some pretty rough injury from Clearfield wheats if they spray the Beyond and Pursuit in too low a condition. You get a lot of crop injury from it. So it's good to always be out there. Unfortunately, those times and temperatures don't always coincide very well. I guess that's just what we know. One of the things we could think about is regular rates of glyphosate. If you start to read your label and your tank mixing, instead of using 32 or 44 ounces, the standard rate on the label is 22 ounces. If you're tank mixing it with something else and you're not, you may be able to come down to a lower rate of glyphosate in those situations. When you guys tank mix glyphosate, what kind of rates are you guys putting in there? Anybody? Right around the 20 ounces with this, yeah. I think when people go more just glyphosate, they tend to, 32, 48, 44, 48 kind of stuff. So I think if, you can come back down and tank, and you'll have to tank mix, but I don't know if I would spray just 22 ounces of glyphosate without any sort of tank mix partner in there. Depends on what I was after, I guess, and what I was trying to do and how big of an area I was trying to spray. So even in the short-term actions, we can think of other products that are out there that might be there for fallow weed control. But I think we have to really read these labels really carefully and think about the tank mix compatibility. Think about where we're trying to go next year, the year after that, because if in some of the things we use, we can have really long plant back intervals if we want to go to mustards, if we want to go to pulses, if we want to go to some other things. We have to think a lot about those plant back intervals that are out there. That was me. I tried to do a 1 ounce rate of Valor in the springtime on lentils, and I torched those lentils pretty good. We'll see how, yeah. So I think you got to think about a lot of that as it comes together. So all these are tank mixing is really what we think about a lot now. And so I come back, are the formulations compatible? There can be physical and chemical incompatibilities. clethodim and 2,4-D, that's a recipe for getting no efficacy. If you put some of those together in the wrong phase, sometimes they have some sort of chemical antagonism. It's called antagonism down here. It's the interaction that reduces the overall efficacy. There's some examples of herbicides where you get better synergism. Actually, saflufenicil, sharpen, and glufosinate actually do really well. I've seen some industry stuff people have been talking about that. They actually have a positive synergism and they understand the molecular function of it now. And so that'll be something, if glufosinate shortage decreases, I would imagine we'll start to see some products that bring Sharpen and Liberty together. The additive response is just sort of, I have this one in here, and this is plus this one, and we'll get a broader spectrum of weed control maybe. They won't be multiplied together to be synergism, but we'll get a broader spectrum of control maybe. So when we think about the 9, so when we're out there making these tank mixes, we've spent a lot of money on the glyphosate. We've looked at our water. We got our AMS, it's ready, it's going in there. We're going to do the best we can. So what are the ways to get the best tank mixes to go together? Well, number one, because we're extension, we always have to say, read the label, read the label, read the label. Mix only a few. Try not to get the products to be more complicated than you need. And sometimes it may be worth the time of just coming back and doing another pass rather than trying to mix in too many things at one time. The jar test is to really check for that incompatibility. When we're mixing things together, make some pre-slurries. So if you have a dry flowable, make a pre-slurry to get it wetted down. You don't want it to hit the tank super clumped. You don't want to have just a little bit of water, dump something in there, get a big clump that's sitting at the bottom and you can't get it mixed up anymore. So make the slurries and get them ready. Make sure you mix in order that's on the label. It's usually specified on the label. Because sometimes mixing in the wrong order can just lead to things that will not then emulsify. The emulsifiers won't correctly. It won't mix up. You'll end up with clumps, chunks, white flakes, precipitates, weird things. And usually it's specified on the label when you really need to worry about it. Mix well. Ensure that the products are mixed before adding the next ones in there. Sometimes you can have problems when if things aren't mixed up and they're still floating around and then floating clumps hit each other and things get all mixed up. And I should say, mix cold longer, but if we're using relatively cold water in the springtime, this mix well really comes into it. You got to mix well as you get it together. And then wait 3 to 5 minutes to allow products to properly disperse in water and get all spread out. It's worth taking the extra 5 minutes here than having something clog or getting a jelly something stuck in the bottom. And then fill the tank 50 to 75% with water, 75% for the liquid fertilizers if you're using a sort of UAN product before we start mixing. Those are kind of the 9 rules of thumb that go into tank mixing or cooking or a lot of different things that we do. But it's always worth slowing down and making sure we get those mixes right. So a lot of people have asked me, what are the alternatives to glyphosate? Glyphosate is so expensive now. I'd be interested to hear what you guys have for alternatives to glyphosate, or if people are thinking about glyphosate alternatives. But this is what I think about. A lot of the glyphosate was cheap. And it was easy to use glyphosate all the time. And now when we try to think of alternatives, we don't have a lot of alternatives that are as inexpensive as glyphosate had been before. When I think about it, I can think of I can think of things that'll control weeds in crop, whether, not in pulses, but I can think of things in cereal crops. We can use a lot of different herbicides in cereal crops. That's not where we're worried about it. To me, I think alternate fallow applications is really what we would have to be thinking about if we're thinking about, or spring burn downs or fall burn downs. But I think those are very valuable applications. And I think where do we have room in the middle is sort of what we think about in fallow. And if you look at some of the other things that are out there that are listed for fallow applications before crops, I guess I didn't put dicamba on here, but there's the affinity products that are out there. There's AIM, which is carfentrazone, which some people we use sometimes, so we don't use a whole lot, but it needs more water. And it's one that needs sunny, warm conditions to really get a good burn down on. There's Spartan Products, the Spartan kind of line, which is the active molecules called sulfentrazone. It's really affected by soil pH. And it's also really used in front of our pulse crops. So we don't want to switch to something that we want to kind of save for our pulse crops or save for some of our other crops that we have out there. Sharpen is also one we tend to use in front of our lentils and our pulses and our things like that. It needs UAN. Unfortunately, it has no activity on grasses. We in the fall we probably mix Sharpen and glyphosate to get mare's tail. Do you guys have a lot of mare's tail in the sort of Conrad area? You guys don't have it yet, huh? You should go stand over at Ledger and blow everything the other way. So mare's tail is a weed. It's mare's tail or horseweed. It's really increased probably in the Mondack part of Montana. It's resistant to glyphosate. All the populations I know. It's kind of in the Mondack area, and it's kind of ratcheting back a little bit along the high line. This last summer, I was out with the producer, and he's like, "What's this weed? I've never seen it before." And he was by Guilford, and he had mare's tail there. And so in the Mondack region, there's a lot of use of Sharpen glyphosate mix to go after mare's tail in front of pulse crops. So fall applications of those. 2,4-D, it only really gets in on the broadleaf plant, on the broadleaf weeds, so you're not killing any of the other weeds. There's Valor or flumioxazin. It's normally a fall applied. Those lentils that I smoked back there in the picture before, that was from a spring application of Valor, actually. But again, it's one of these, we don't have a lot of options in pulse crops, right? So I don't want to say, these are the alternatives, but then when you come back around, you're going to go into a pulse crop after that, and you're going to need the same herbicide in that way. And these are relatively expensive herbicides. Paraquat for burn down applications is probably another one. I mean, it's a toxic molecule. The lethal dose for a human being is two tablespoons. That always kind of freaks me out. People worry all about glyphosate, but there's a lot of stuff out, that one to me it's toxic. We use it a lot. It'll get the small annual weeds in burn downs. It can be put in a lot of tank mixes. And so we should keep that in mind. Anybody else have any ideas, since you guys are the master farmers in the class? Anybody have any other glyphosate alternatives in any situations or scenarios? Are we addicted to glyphosate? Okay, well, that's my last. We'll talk about it at the end as we come off of it in the end. So I think those are what I could think of as alternatives, but I think they're also probably about the same price as glyphosate these days. They're expensive molecules. So I made the comment, are we addicted to glyphosate? There is opportunity in this challenge that we do face, that we should take this as a shot across the bow in some ways of, okay, how do we make sure we're not too addicted to glyphosate? Little bit of addiction's probably okay. Too much addiction could be a problem. Glyphosate faces a number of challenges that are out there. There's in the short-term price and supply, but I think that will work. Those kinks in the system will work out. There's increasing resistance of weeds to glyphosate. I think that's an increasing problem that makes it hard. That's why I say the hardest challenges people come with me to, I can't control this kochia and fallow, is, that always makes me worry a little bit, and mare's tail and some of the other ones. Just last week in southern Alberta, they confirmed glyphosate resistant cheatgrass or downy brome. They confirmed it in 2019 in eastern Washington. The good news is I tested some populations. We don't have it yet. That's good. Actually, some agronomists sent me, an agronomist from Fairfield, he was like, oh, I'm sure this is resistant to glyphosate. But we sprayed it before Christmas with 32 and 64 ounces, and it dead as can be, so that's good. But we have to know that we should expect it at some point, we should expect glyphosate-resistant cheatgrass. And then I think when it comes down to using desiccants, maximum residue levels have come down in a lot of countries that we export our pulses and our agricultural commodities to. So it's harder to use glyphosate as a desiccant later on in the year. So I think there's a number of challenges. So what do we really do when we think about it and we go forward? And I get to stand up here and I get to say, integrated weed management. It's the combination of prevention on the bottom. We should prevent new weeds from coming in. That's a Palmer amaranth water hemp story. It's a different story. But when we're actively managing weeds, we have, can we integrate any biological control? We have chemical control, and it's not that chemical or herbicide control is going to go away, but we have to be we have to recognize that we can't put on too much selection pressure or we get more rapid resistance. What can we do out there for mechanical things? And then what sort of cultural things can we do just to sort of stack it up? It's often referred to as the many little hammers. We can have one giant hammer and we can drop it on the weed, or we can come at it with a lot of little bitty hammers. The big hammer tends to lead to pretty rapid resistance, and the little hammers, the idea is to keep it, put a whole bunch of different selection pressures and little hammers on there to keep the weeds under better control. That's the idea. But you know what I say to that? It's easier said than done. We can stand up here as academics and, all these things like that, but it's actually, it's not an easy thing. When I was driving up from Great Falls this afternoon, I was looking out and I was stopped and looked at the edges of a couple fields and was looking around. It's not that hard to switch up to, we have so much no-till out there, and our no-till, what makes no-till possible? What makes herbicides make no-till possible? If we didn't have herbicides, no-till would be essentially not possible for us. We did a project. I don't think I'm going to talk. I'm not going to talk about it today, but we did a project outside of Bozeman, and we had 36 months of no-till organic, where we had a cover crop. We had sweet clover cover crop in there. We had a bunch of grazing in there. But we tried not to till the soil for 36 months out of a 60-month, a 5-year rotation. Whew, it was a weedy mess, I tell you what, when you take that out. And it's really, when you take that tillage out. So it's one of the things that is easier said than done. But we've tried to do a number of different projects on it, and we've been working on it. I've been at this job since 2018, July 2018. So I had a year and a half of no COVID before we came in. But so we did this project up at Central Ag in Moccasin. And we said, okay, how can we manage wild oats without herbicides using integrated weed management? And so we racked our brains and we did a bunch of different things. We had 10 different treatments and we wanted to know what the outcomes were. We wanted to know if wheat height made a difference, and not among varieties, but within a variety. So we took this old variety Amidon that was, sometimes when I say Amidons, some of the old timers are like, I remember that thing from that variety from 1980 something. And so we had a high seeding rate, a low seeding rate, a tall variety version, or a tall version of Amidon and a short version of Amidon. And then we had some lentils that were in there too. So this was 60 and 90 pounds per acre, I think, of seeding if I convert those correctly in my head. Were the seeding rates, so 60 and 90 pounds. And then we said, will that make a difference in wild oats? And then we had a number of forage crops in there. We had a winter triticale Austrian winter pea mix. We either grazed it or hayed it in the springtime. And then we had a spring barley spring pea mix and and then a hayed spring barley spring pea mix. And we grazed sheep on them out at Moccasin, and we wanted to know how many seeds did the wild oat make, how big, how robust was it in this project. And what we found out was at a lower seeding, I figure out which direction I want to say it. So at a higher seeding rate of wheat, we got lower density of wild oat tillers, but still a lot of wild oat tillers compared to the low seeding rate. But maybe it's a little hammer knock on there. You know, it's like death by 1,000 cuts. We can get one cut out of this right here. So we got slightly less. When we had more wheat biomass, so the high seeding rate, we got more wild oat biomass with the low seeding rate and the high seeding rate. We didn't get a lot of really big differences, but we did get the separation in these two lines, and that was really the point, right? As wheat biomass went up in the crop, the amount of wild oat biomass went down. And this was the low seeding rate, and that was the high seeding rate. So we got less wild oat when we had a high seeding rate and had a good stand development. But when I think about that, you know, it's really not a game changer kind of thing. It was like, yeah, we had 75 wild oat plants versus 100 wild oat plants. Either way, that's still a lot of wild oat plants. What was interesting and actually did a pretty good job was to integrate the grazing and the forage crops into it. So we had the fall planted triticale and Austrian winter pea, and then we had the spring barley pea mixture. And this is the wheat high seeding rate that we put in there before. And this was the number of seeds that were made this time. So I switched over to the number of seeds. And what you can't see is there's a bar missing right here. And then there's this bar right here. And that's really having this forage crop that was in there. So what did we do with the forage crop? We have wild oat infested field. We put this triticale or barley in there, and we came back and we cut the forage crop when it was kind of at the soft dough stage, which was beginning of July, if I remember correctly, kind of first, second week of July, something like that. We got this soft dough stage, is decent forage quality. This was 2018 and 2019 when we didn't have a lot of worry about drought and nitrate issues. Actually, 2019 is the only year I've ever successfully grown a warm season crop in Montana because it rained more in the actual summer. But what we did, the take-home point is when we put this triticale out there and we put the barley out there, the wild oat and these things were growing at the same time. It was suppressed, but then we came in there and we cut the wild oat and we cut the plants off. So that basically stopped seed production of wild oat for that year. You could follow it up with a burn down herbicide that, kills the cover crop, kills everything, or a tillage, or however you want to clean it up in the end. But there was value in actually reducing the seeds that went back into the seed bank by putting that forage crop in there. And a lot of times people have said to me, yeah, that's just, not all that possible. I'm not going to do it. There's no value in it. But, this year, if you would have had a forage crop that you took off in early July, and it would have been decent forage in a year where there's low forage values that were floating around, low forage out there on the landscape. So I think one of the integrated things, you probably don't want to do it on a really big field, but it works on a relatively small field, depending on your operation, your neighbors, or something like that. So we did another project in 2018-19 when I started, and we came into the end of a project that they were doing at the Northern Ag Research Center in Havre. And it was an 8-year rotation. It was a cover crop, winter wheat, spring wheat rotation. It was either of them. You had the spring wheat here, the winter wheat there. And we looked at crop yields, weed suppression, water usage, microbial communities when we think about soil health, and then the effect of warmer and drier conditions. So we manipulated the conditions within a year to make it warmer and drier. This is kind of what it looked like. So one year it was this, the next year it was this. And I just simplified it to think about winter wheat. But we had an early cover crop mixture. We had a mixture that was more of a mid-season cover crop mixture. And then we compared it to fallow. So what was in those mixtures? So in the early, we had Otana oats, we had purple top radish, Arvika peas, we had groundhog radish in there, and we had hairy vetch. In the mid-season mixtures, really it was kind of the same. It was oats, there was some vetch in there, some radish, but there was golden German millet in there, and then there was a sorghum Sudan mixture that was in there too. There was also some Cheyenne soybean was in there. So we had the early and middle mixture. And so we talk about cover crops a lot. Who hears about cover crops nearly every day on the internet? Some guy in the Midwest who gets 50 inches of rain a year, has a constant cover crop, and it's great. And we're in Montana and we get 12 inches a year in a good year, and it's dry, and everyone's like, use cover crops. And you're like, do you know what it does to the soil moisture? There's a reason we have fallow in Montana. We didn't just make up fallow because we thought it was fun to not have a crop in there one year. And so, but when we did this project, you could tell I get annoyed with those cover crop discussions. So we monitored soil moisture. So this is soil moisture, that's in fallow. This is in the early season mixture, the mid-season mixture, and then this is in wheat right here. And this is the date going from, this is May 30th, June, July 30th right here. So this fallow, so this is 0, that's the most water we could have, and the most negative number is the most negative we could have on here. So does fallow work? Look. The soil moisture stayed basically up there the same. Look what it did in the early season cover crop mixture. Look what it did in wheat, right? This is, I should say, 2019 is the year it rained in the summer. The NARC field day, it rained 2.5 inches just at the field day. Yeah. And the mid-season mixture, well, it didn't make as much biomass, so it didn't use as much water compared to the early season or compared to the wheat. So there's a reason we have fallow in our mixture. So if we think we're going to use cover crops, we have to understand it's going to lead to a trade-off, right? It is going to use moisture that we want to have in that soil. But maybe there are cases when it's actually worth it. So this is the cover crop biomass right here. And this is the early season mixture. I haven't really concentrated too much on the ambient and warmer and drier conditions, but what we did is we put like a plastic hoop around it and it heats it up a couple degrees, and we took 50% of the water off by having a structure over the top of it that removed the water. So there was some differences in there, but really the early season cover crop mixture, because it grows better in cool season, it had way more biomass. The mid-season mixture with sorghum Sudan, with the C4 grasses, it didn't make as much biomass. The interesting thing when we think of the cover crop mixtures is, who's heard of cover crop cocktails? Cover crop cocktail, right? Cover crop cocktail is someone's like, let's put a little seed of this in there and a little seed of that in there and a little seed of this and a little seed of that, and then we'll give it a cover crop cocktail sort of mixture name. But a lot of it is things that may not necessarily grow or make a lot of biomass. I would call our early and mid-season mixtures, those are cover crop cocktails in some ways. But a lot of the research has actually shown lately that just one or two, or just having a grass, a brassica, and a legume in there is enough for having a mixture. We don't need to spend a lot of money on complex cover crop cocktail mixtures. But the one thing that did come out of this study, I would say, is in the warmer and drier conditions, and I'll show it to you a little bit, it's kind of writing a reinsurance policy in there, is that oat and radish biomass changed a lot in the two climate treatments that we have. So this was the cover crop mixture when it was just ambient conditions and you look down on it. You see all the oat biomass that's basically in there. But then when we warmed up these structures with these open top chambers is what they're called, look how much more radish biomass mixture was in there for that year. So there's kind of, my advice is don't pick too crazy of a complex cover crop mixture because the seed costs money. It's very complex and you don't necessarily know what you're going to get. But it's also, you don't want to necessarily land with just one cover crop mixture. Say I just planted oats that one year and it was a warmer and drier year. Well, I'd get less oat biomass over here and might say my cover crop didn't look very good. But just having this mixture of the radish in there really brought that biomass back up. And if you want to, the best thing to do for weed competition is biomass. You just want to have green mass. You want to have cover on there so that the weeds aren't as competitive and don't come up through that. So if you're using a cover crop mixture, it pays to have a slight mix, but don't go too much. This was the wheat. This was the wheat yield and grain. This is the grain yield of wheat. So in 2018, we had a year that maybe we don't really know what happens, but you have this ambient condition. We didn't see a difference in grain yield between fallow, between the early season cover crop mix or the mid-season mixture. We had lower yields when it was hotter and drier. I think that's something we already know. But then in 2019, when we did this again, if you look, the fallow yielded way more grain than the early season mixture, where it had preceded it by the early season mixture or the mid-season mixture. So there may be there's a trade-off that you have to make in reduced yields probably. And it probably goes back to that water, the amount of water that's stored during that fallow year. Here, having more of that fallow water in here probably made a difference in that one. But I will say that the cover crop this is the weed biomass. Here's the amount of weed biomass in fallow. Higher, way higher amount of weed biomass in fallow. Way less weed biomass in the early season, and even in some degrees the mix in the mid-season. And the early season, again, there's way less weed biomass in those plots. And the early season mixture lands somewhere in there in the same. So Cover crops present these complex trade-offs in integrated weed management, right? Uses more moisture, it may ding us on yields, but we do get things out of it like weed suppression, and then also changing soil health and working on sort of soil health properties. So we looked at the microbial communities. What happened to the microbes in the soil when you had this long-term cover crop wheat mixture? And there's some pretty interesting things. So this is the amount of mycorrhizal fungi in types of mycorrhizal fungi that you found in the soil. There's more fungi in the soil when you had a cover crop mixture in there over that 8 period years. So if we're thinking about soil health, you know, one of the things that cover crops actually do provide some benefit in that context. And then if you look over to fungal pathogens, when we took out just the group of the fungus that were fungal pathogens, in the early season and in the mid, we had less fungal pathogen spores. So our fusariums, our things like that. And it may have been tied to having these brassica cover crops in there, that they can be somewhat, they make a molecule called glucosinolate, and it's sort of an antifungal, antimicrobial, it's the antimicrobial properties of it. So it's a hard trade-off to make. Integrating the management's easier said than done, but I feel like we spend a lot of time talking about soil health and all these things now, and it really integrates into weed management and into all the different types of agriculture that we're doing. So this just sums it up. The trade-offs: you use more water, you get less weeds, you might have better soil health. So I think it's up to each individual producer to decide what they're going for here. Sometimes when I talk to agronomists, they're like, I would just rather have a continuous cropping system. I know my yields from year to year to year are going to be lower, and I'm not going to have the, crop fallow sort of yield spikes. And maybe I can just have something where I get a yield that's more even across and I can keep plant roots in there all the time. We're thinking about soil health. There is the potential for forage. I think it's something that won't go away. I think we'll face more hot, dry summers. We'll need forage sometimes. And I think there's some potential in there to use it as a tool for weed management as well. And all this together shifts the weed selection pressure and maybe reduces some of our dependence or our addiction to cheap glyphosate. So I don't have too many, how far am I along? Oh, I've already gone for an hour? No. Really? I could talk about this a lot. So let's come back. Mechanical weed control. We're a no-till state. There's not many, well, I was actually surprised to see the amount of bare soil that I saw driving in today. We do. Some situations, harrowing could be appropriate, or we have these, they're chisels, but they're not these super wide sweeps. You guys ever seen these wide sweep points that are super wide? These aren't that wide. But we use this for some annual weed control, relatively shallow. We're putting it about that deep into the soil surface to knock down weeds and get small annual weeds. Generally, I feel like it works good on annual weeds. Doesn't work good on perennial weeds. But this is the oldest, steel in the field is the oldest thing we've been thinking about to manage weeds. I was talking today about someone using a tine weeder. Do people use tine weeders around here? No. So when I was 17 years old, I had this job. My parents immigrated from Germany to the US. And when I was 17, I stayed with my grandparents for a lot of that summer. And I had this old Fendt diesel tractor. And then it had this tine weeder on the back, which in German is called a Hochstriegel. And oh man, I just spring wheat. I just used the tine weeder on spring wheat, and that Fendt diesel, I can still hear the motor. It just you always sounded like the motor was just going to throw a rod or do something. It was a really loud, ding, 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 ding. And I went back and forth 17. That was the year I learned to drink beer too. Yep, 1996. I have fond memories of it actually. But I used the tine weeder, and it was a blind passage before a spring weed emergence, and then an in-crop tine weeder emergence too. You'd go along the rows. Sometimes we'd go perpendicular to the rows. But tine weeding doesn't work if the weed's that big. Tine weeder, you can forget about. It doesn't work. But what are we thinking about in the future? So there's the precision technology, and it's going to be kind of cool. At MSU, we're going to get some new precision technology people who are going to be working at MSU. And it's, where do we think about technology? Where does precision weed control go into the future? And will it work? And how do we implement it into our system? So I still think it's a pretty young technology. With some of the Weed It, has anybody ever tried the Weed It sprayer or seen the new John Deere? Yeah, exactly. That's why I'm so cheap that, yeah, I'm like, how do I make my own poor man's version of it? But there's the Weed It precision sprayer out there. John Deere has a new sprayer out there that does precision spraying. It has the ability to massively reduce chemical use in some situations. I think there'll also be times when we'll use them to target hard to control weeds with higher, where we'd use a higher rate or a much more expensive herbicide. I think fallow seems like the natural place for us to start. You basically got green on brown. It's not as hard to detect it with cameras and some of these things. So I think these will be where we come into the system. This reducing overall chemical usage, I think it's really can happen. I worry that we're going to select for resistance in weeds in a way that's not necessarily super intuitive. So, and we've seen it with cheatgrass before, right? We go out and we spray cheatgrass in the fall, and we wipe that cheatgrass population out. Well, what comes? There's another flush that comes a little later. And then we don't have time to go chase that one up. Or in the springtime, we notice that cheatgrass is starting to germinate and our residual herbicides are wearing off a little bit. We think of herbicide resistance as only being like, I applied this molecule, the plant went through a mutation, now it's resistant. But really, resistance can come in forms of, and it's happened with the plow out there. We've already seen it with the plow. You go out there and you say, oh, I wiped that weed population out. Well, it pushes that population to germinate at a different time. It pushes it to do things that you wouldn't necessarily expect it to do. And so in cheatgrass, we've seen it a little bit. We might be really good at picking up all the fall populations, but then all of a sudden we notice we have populations that have sort of adapted and will grow in the spring and start to grow before we can go out and spray or do things. It's sort of, you can avoid something in space and you can avoid something in time. And that's an example of avoiding something, the weed avoiding the chemical in time. So I think, we might push certain weeds in that direction in that. That's what I think about at night. So this is actually, so I've talked to this company. I went through and I said, Montana, we have a lot of wheat fallow. We have a lot of space where we could use different types of tools. And I've called and I've talked to quite a few of the companies who are thinking about robotics and autonomous robots and things like that. And I would say the technology is too young to get to us. They're mostly worried. They see dollar signs in the Central Valley of California for lettuce, for vegetable production, things like that. But they're starting to move in different ways. And so there's mechanical robots out there that'll go through and they have cameras that'll sense the plants and the rows and do all these things. And they'll do mechanical removal and you could kind of turn it loose into the field. And I've seen it in quite a few situations. And then there's some other things that are coming forward. And I thought I'd play this video if it works. This is actually, I think this is this is Carbon Robotics, and they're an autonomous weeding company, but they're using lasers to zap the weeds actually, and you can kind of see if we can see if it happens. We'll see if it works. So most of it's Central Valley, California, some of it's Eastern Washington. But can you see how the camera's detecting this stuff in lettuce and zapping the kochia? If we could have a robot like that for our herbicide-resistant kochia, I think it would be really cool. Oh yeah, I should warn you there, like this can cause people to, yeah, see there's the zapped kochia right there, or the zapped purslane, and that was the onion next to it. So it's a supercomputer, and it weighs a whole lot, and it takes a lot of computing power, but I think in the future we'll kind of keep coming in that direction a little bit. I think one day we'll have ability to put robots out on the field that will do some of this mechanical weeding, laser-based weeding. Yeah, so there's some of that stuff coming, but that's sort of the far end of the future, the long term as we think about it as we go ahead. So with that, it says I've been talking for almost an hour and 7 minutes. So I'll just end it right there, and you guys can ask me any questions, or I'll ask you guys questions and we can discuss. And if anyone has any questions online, they can type them into the chat box and Adrian will read them off. You guys have any questions, comments, research directions you guys want to see MSU go in? We get 4 new precision ag hires coming up. We get a couple things. And what do you guys want as stakeholders? Nothing. I'll just sit in my office all day. And watch YouTube videos about lasers and kochia and dare to dream. 6 years. Well, it'll stay, yeah, 6 years, it'll be, so yeah, I've been doing the drought and weeds talk a lot, and I've actually have that one down. I've been talking about kochia and wild oat, comparing them. So kochia seeds are really, or wild oat seeds are really long lived. When we do herbicides, when they fall off the plant, they are dormant. There is nothing you can do to make them germinate. There's one thing you can do, and this is what we do when we do resistance screening in the lab. You take one wild oat seed, you peel it, and you poke a hole in it with a needle, and then water can get through the seed coat for it to germinate. Otherwise, it won't, like a whole year, it will not do anything. We actually sell some wild oat seeds to FMC, the chemical company, and we're pretty good at actually having pretty good wild oat seeds, but we don't give them to them for a whole year after we harvest, because that first year they won't germinate. After like a year, they'll germinate at 80, 90%. And so wild oat will last 6 years, but usually when it's buried at a depth of 0, 4, 6 inches, something like that, if it's buried in the soil profile, it lasts a lot longer. If it's on the surface, its mortality is a lot higher. So it's like 60, 80% seed mortality in the first year of the whole lot. But if it's buried down there, they'll last for 6 years and come out. Field bindweed, 20 or 30 years. So you can clean up a field bindweed problem and be like, oh, that LV6 really took care of it, but there's, you know, there'll be plenty more in the seed bank that's in there too to come out. But kochia is much different. Kochia is 2 years maximum. It will not live any longer than 2 years. And kochia basically, its strategy is I germinate now, I have to no matter what, and it's super drought tolerant. In the drought and weeds talk that I've been giving, I show that Valor actually requires more moisture to be activated in the soil than it takes for kochia to germinate. So kochia germinates with less water than it takes to activate Valor. And so when you have some people call and say, I got a Valor wreck. I think Valor didn't control my kochia. It must be resistant. And really, it's not. It's really, kochia is just more drought tolerant than Valor, the herbicide, is. Mm-hmm. Mm-hmm. Huh. So they're putting down Axial and Fargo in a year? Well, that's a long history in wild oat. It goes back to the fair. Some of the first resistance that they found was off the Fairfield bench, and it was resistant to Fargo a long time. You know, that was early 90s, I think, is when they first found that. So Fargo resistance to Fargo and wild oat is really widespread from Fairfield bench in, I don't know about how far it goes in this direction, but yeah, it was just the choice. So I would imagine, and that's in some ways playing with fire too, because I think we probably have some axial resistant, group 1 resistant wild oat herbicide populations out there too. So they're stacking both of these modes of action on top of each other, and they both have fairly high risks of developing resistance. So I think that's a tough situation to be in right there. And so we rely on other herbicides then to take care of that sometimes. The Everest, people switch to Everest a lot and get pretty good wild oat control with it, but it has really long plant back intervals into pulses is one of the big limitations on that one. Yeah, Gold Sky, the Sky. Yeah, what's on the market? Is it Open Sky, Gold Sky, and they all have starring in them. Yeah, starring. Yeah. And I think, that's been working. Yeah, and that's been working now. But you kind of want to protect that, right? We want to protect that line of products because we don't want to find ourselves in a situation where we don't have any options. Yeah. That's a good, I don't have an easy answer to that question. I think it's a hard one to. You would mean, so when you're asking the question, asking it in concept of, do I use axial for 3 years and then switch to something else for 3 years? Or do I do an every other year kind of thing? Yeah, I don't think I have a super easy answer to that one. I don't have an easy answer to that one.
Axial every year.
Oh yeah. Oh yep. Yep. But you will definitely have resistance. Yep. Yeah. Yeah, I would say the goal is to be as diverse as you can be. Have some different selection pressures in there if you can. That was why we did that wild oat project. It was actually because we're starting to see more resistance to axial in Montana into these grassy herbicides and clethodim and the pinoxidins, the ops and the dims of those grassy ones, and to the Fargo, those sorts of herb molecules in there. And there's a little bit of group 2 resistance. If we ever got resistance to like Everest, say, for example, then you get into being in a pretty rock and a hard place, especially doing in-crop wild oat control. It becomes pretty hard. But I don't think I have an easy answer to that. Should you do, same, and then different? Yeah, I would say probably. I would just almost say in time, I don't know. That's an interesting question. Actually, I'm going to ask them. I'm going to ask next time I come back and ask me that question. I'm going to talk to some geneticists about that and think about, what the metaphor I actually have used it before is, there's there's an old Chinese philosophy book called the Tao Te Ching, and it has what I call the roofer's lament in there. And it says, rock is hard and rigid and does not yield, but water is soft and liquid and yields, but water always gets where it's going. And so in the same way, we have to think about, we're trying to manage all these pressures at one time, but we don't want to be too rigid in one single pressure, because the wild oats, like the water, it just goes around us and gets where it's going in some ways, and no matter how we do. So I think we want to be unpredictable to the weed. So my gut answer is to say switch more often rather than come 3 years same, 3 years different. But I couldn't point to something that said that. Yep. Mm-hmm. Yep. Yep. Lots of, yeah. And the barley acres. Yep. 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 Yeah. Yeah, you should be able to. And think about it in the I didn't really talk about it in the integrated weed portion of it, but you really want to drain the seed bank. You know, the seed bank is the number of seeds that are out there. And the smaller that is, the less weed pressure you have, but also the less chance you have to develop resistance. So if you had 1 million wild oat plants and you hit them with axial every year for 5 years in a row, the chance of getting resistant wild oat is much higher than if you had 100 wild oat plants and you hit it with axial 3 years in a row. So the idea is to keep that seed bank down as much as you can be, as much as you can. Yeah.
You don't disturb that.
Mm-hmm. Yeah. If it had in good, yeah. I mean, it might get eaten by a bird or a mouse or a vole or, whatever. There's the fate of that individual seed. But if it were just in good conditions and it were an inch below the surface, it would a year. And that slowly but surely that water works its way through the seed coat. Yep. Yeah, I think that's when it comes from depth. That's a depth thing. If they're 3 inches below the surface, then yeah, you don't disturb them and they won't come. If you went through there with the cultivator and you turned all that stuff up, it would be a sea of wild oats because you had that store below the surface. Yep.
Since we quit.
Mm-hmm. Yeah, and multiple people have said that to me actually. And because we traded wild oats for cheatgrass in some ways, right? In the no-till system, because really wild oats more of a weed of tillage than it is a weed of no-till systems. But what cheatgrass and kochia, they love to germinate on the surface of the soil. And so when they germinate really well in that no-till duff on the surface. Yeah. So in some ways, when we went no-till, wild oat probably went down, but cheatgrass came in and took over that spot in some ways, especially in winter wheat, probably more winter wheat more than spring wheat. Yep. And that's because winter wheat and cheatgrass, yep. Mm-hmm. Yep.
We gotta get it. Then you know.
Yep.
Now you're up again.
That. Yep. Mm-hmm.
Plant backs also.
Yep.
Those chemicals.
Yep. Years. Yep. Yeah. That's an interesting spring wheat, winter wheat. Yeah, someone out in Big Timber this year was like, I got a horrible cheatgrass problem in my winter wheat field. And I said, how long you been growing winter wheat? And he's like, oh, 15 years. And I was like, absolutely. So because it's what you just said, right? In the fall, you come out and you can spray that, you can spray it and you can get rid of the fall flush of cheatgrass. And then if you're planting spring wheat, you can come back in and like put a glyphosate or put something down in the spring and catch the rest of that flush. But if you have winter wheat in the field there, then it's a harder thing to deal with because you can't go in and just get that generic burn down that you'd hope for. So that's the crop diversity thing of just alternating the timing of those applications can do a big sort of push of sending that weed community in a different direction. Because one year you're selecting for spring. So if you go and plant spring wheat, well, what do you get? You get the late season weeds that come trailing in there once the residual starts to wear off and then it starts to grow. But spring wheat's pretty competitive, but you get the late season weeds. And in the winter wheat, you get the winter annual weeds, right? The henbit, the flicks weed, and all that stuff that you can't clean up. And so that's kind of the diversity of mixing spring versus fall planted crops in there. You can kind of mix it up a little bit and just push that weed community in a different direction. Yep.
Have you had a test done, or have there been tests done on conventional seeding versus the disc growth?
No, that would be an interesting one to try out, though. I think the more disturbance, you get more weeds. Yeah. Yeah, that would be my working hypothesis if I were going to do it. My hypothesis would be the more disturbance you get on that surface of the soil from putting the seed down, the more weeds you're going to get. But it'd be an interesting one to test. That'd be a kind of a cool one to test. That would be, yeah. We've been trying to think about, in some ways, this is very different and off topic, but how do we build good agricultural experimentation going into the future as a university? And we can go to all our different research stations and do things. But as we start to get into the precision world and we start to get into other things, I think some people, we see the value of doing more simple on-farm experiments with a whole bunch of different cooperators. You can do 5 experimentation trials, or you can get 50 people across the state to do a simple experiment that might be, planting day, nitrogen, phosphorus. There's a whole bunch of different things, and there's the power in that sort of big data. We'll call that big data is what we think about it. It's not that we just have our sample size equals 30. We want our sample size to be 10,000, and we want to look at something relatively simple. So we've been trying to think about that a little bit at the experiment stations and with some of my other collaborators, and then farmer collaborators. How do we build bigger networks of experiments that make it easier to provide useful information to producers? And I think it's in a fluctuation, right? In how we do it, because Facebook, all these other people, they're taking this big data and they're doing these experiments already. And I think there's room in agriculture for us to do things like that as better collaborators between agronomists, companies, producers, and things like that, where we can build some better experiments. That's the other thing I think about at night. Yeah. It'd be cool to sit down sometime and have a good summit discussion among a bunch of people, come up with something like that. I drank my 6 o'clock coffee.
Okay, well, thank you, Tim.
You're welcome. Yep.